Good morning, students. In this video we'll study about the density bottle and the density of liquids, and we will also go through the laws of flotation and laws of sinking, how the body floats in the water and how the body sinks in water, or how the body partially immersed and partially floats in the water. So the first topic is density bottle. Now students, in this diagram you can see this density bottle. This density bottle is made up of glass and it is having a volume of 25 or 50 ml. It contains the water of 25 or 50 ml, and it is having a hole over here, and this is the glass stopper. Now this glass stopper helps the extra amount of liquid flow out of this density bottle. So the measured amount will be kept in this bottle, that is 50 ml or 25 ml. In the book it is written as density bottle is a specially designed bottle which is used to determine the density of a liquid. You can see in the figure it is a small glass bottle having glass stopper at its neck. The bottle can store a fixed volume of liquid. Generally the volume of bottle is 25 or 50. The stopper has narrow hole through it. With the help of that narrow hole, the excess amount of liquid drains out or it comes out. Thus the bottle always contains the same volume of liquid each time when it is filled. So I hope students you have understood this. You can see this picture given in your book. Now with this density bottle we will come to know about the numerical part. We will, with this density of liquid, will help to solve the numerical part relating to the topic density of liquids. Now how we find the density of liquid? To determine the density of liquid using density bottle, what we do, we first wash the bottle and we dry the bottle. Then we measure the weight of the empty bottle, which is marked as mass 1 or M1, which is in grams. Now we will remove the stopper and fill it with water, and then we will replace this stopper. Then what will happen? Excess amount of water will flow out of the glass bottle, and then again we will wipe the bottle all around, and then we will measure the mass again, and then we will measure it and we will name it as M2 grams. Then again we will empty the bottle and dry. Now we will fill the bottle with some other liquid. Some other liquid can be like alcohol, etc. And then again we will replace the stopper, and then again extra amount of liquid which is kept inside the bottle will come out, and it will be termed as M3. Now we will calculate the mass of water, which will be M2 minus M1. M2 was the filled with water and M1 was the empty mass. So we will subtract it from the empty mass, and then again we will find the mass of liquid, which is M3 minus M1. M1 is the empty mass of the density bottle, and then we will find the density of liquid, which is mass of liquid upon volume of liquid, that is M3 minus M1 upon M2 minus M1. So this is the example given in the book. We will also solve the numerical part afterwards with the help of this activity. Now I hope students you are clear with this. So in this method we are going to solve the numerical. Now comes the relative density. The relative density is something Relative, you can see the word, you can just understand with the word relative. Relative means it is related to something, or it is connected to something. So relative density of a substance is defined as the ratio of the density of the substance to the density of water. Because it is related to something, so it is the density of the liquid to the density of water. So it is always compared with the density of water. So the relative density of a substance is density of a substance upon density of water. For example, if the density of iron is given as this much and the density of water is given this much, so the relative density of iron will be density of iron upon density of water. This will be the answer. So I hope, student, you are clear up till now. Now another important thing is that relative density do not have any unit. You can see it is given in the book. Relative density is just a number. It has no unit because it is written in fraction, or it is written in ratio form. So whatever term is written in ratio form, it does not have any unit and it is dimensionless. Dimensionless means it is not having any type of dimension. Like for example, as we have dimensions for density, that is gram per centimeter cube or kilogram per meter cube. So in this way it is not having any of the units. It is dimensionless because it is ratio quantity. Now you can see, students, in the next page you can just go through this chart. In this chart it is mentioned the density in grams per centimeter cube and kilograms per meter cube, and relative densities are given in it. You have to just go through this chart by your own. Now we're going to start the principle of flotation and sinking, and we will just go through this topic one by one. We are having 3 cases in this, so we will just go through all the cases. Now you can see the first is floating and sinking. Now floating is something, you can see, if there is a ball, or you can say if there is a tub or a bucket filled with water, this is water. Now if we throw something in this, the body can either float means it will be on the top surface of the water, or it will sink down in water, or it will half float or half submerge in water. So for this we are having 3 cases. Now if we take the example of a nail, if we just drop a nail in this water, what will happen? This nail will sink down. Why? We will study in the cases. Then if we just drop a piece of paper, the piece of paper will float in water. The reason we will study in the case. And suppose if we drop a ice cube, you will see the ice cube will partially float and partially submerged in water. That is, it floats half and it is half submerged in water. So thus we are having 3 cases in this flotation and sinking. Now first we will go through the principle of flotation. Principle means there are certain rules which flotation, a body which floats, it follows. What is it? Let's see. When a body is immersed in a liquid can be anything. It can be oil, alcohol, it can be milk, glycerin, mercury, or anything. The following are the 2 factors act on it. The first one is the weight of the body, that is W, acting vertically downwards. This force has a tendency to sink the body. Then we have buoyant force. This is very important. Buoyant force of a liquid, that is FB, acting vertically upwards. The buoyant force is equal to the weight of the liquid displaces by the immersed part of the body. This force has tendency to move the body up. This is why buoyant force is also called upthrust force. Now, when the body is thrown in the liquid, it has a property to move vertically downward. Whenever we are throwing a body in the liquid, it has the tendency, always a force acts on the body. Suppose this is a body, a force is acting on this body which tends this body to move down in water. But there are certain cases, and whenever we throw a body, there are certain forces which act on the body, and that is called upward force, which is given from the water by the body, will tend the body to float in water. Now for this we can take the example of a iron nail which sinks in water, and we can take the example of a ship. Now student, if you take the example of ship which is carrying lot of people in it, but still it do not sink in water, the reason is the ship splashes the water. The ship splashes the water in the water body, as it is having the volume at its base. It splashes the water as the volume of the base of the ship, and an upward force also act on this ship. That is why ship floats in the water, whereas iron nail sinks in water. Now let us consider the cases which is given in the book. The first case is weight of a body. The weight of a body W is greater than the buoyant force Fb. Now the weight of the body W is greater than the buoyant force. So when the weight of the body is greater than the buoyant force means the upward force which acts on the body. Now in this case can be the example, in this case we can give the example of iron nail. Now what happened, the density of iron nail is greater than the density of the liquid which is taken, and that is why the iron nail sinks down in the water. Now you can see in this case the resultant force on the body is W, that is weight of the body minus buoyant force which acts downwards. The body will sink in the liquid to the bottom under the influence of the resultant force W minus Fb. Now this is shown in the figure. You can see this happens when the density of the solid is greater than the density of the liquid. The solid can be iron, it can be copper, or any denser part which is denser than the liquid which is taken. The next is the second case, and the second case is saying the weight of the body is equal to the buoyant force. What will happen in this? The resultant force of the body will become 0 if both are equal, that is the apparent weight of the body is 0. The body will float just inside the surface of the liquid. This is shown in the figure, and in this we can take the example of ice cube. This happens when the density of the solid which is taken, for example ice cube, it is equal to the density of the liquid which is taken. The liquid can be alcohol, mercury, water, glycerin, etc. The next part is the weight of the body W is less than the buoyant force. Now what happens when the weight is less, when the weight of the body which is taken is less? If the body is completely immersed in liquid, in this case the resultant force acts on the body upwards. The body will float partially above the surface of the liquid only. That much portion of the body will submerge inside the liquid, by which the weight of the liquid displaced FB balances the total weight of the body. In this is shown in the figure. This happens when the density of the liquid is less than the of the density of the solid is less than the density of liquid. Now for this you can take the example of piece of paper, you can take the example of cork, you can take example of plastic, any plastic piece, etc. In this case the body will float on the surface of the water. Now what conclusion we have found it out? Thus the body of density greater than the density of liquid sinks inside the liquid, while the body density equal or less then it will float in the liquid. If it is equal or it is less, it will be floating in the liquid. Now there are some activity which is given in your book. This activity you have to read on your own. Then we have the another important thing is the apparent weight or a floating body is zero when, in other words, according to the law of flotation, the apparent weight of the floating body is zero. A body floats when its more portion outside the a body floats when its more portion is outside the surface of liquid or more density than the liquid of low density. Thus it can be demonstrated in this. Now student, what they are saying in this paragraph is that a body will float only and only when the solid which is taken is very less dense than the liquid which is taken. In that case the body will totally float on the surface of the liquid. For this you can take the example of piece of paper, a piece of feather. It is very light, so it always floats on the surface of water. Now we have some applications, or you can say we have some examples of flotation. And the first is flotation of iron ship, then the flotation of man, flotation of ice on water, then we have the icebergs, and the next one is whales and balloons. These are the applications which is given in your book. The first is the flotation of iron ship. So what happens in this? A nail made up of iron sinks in water, but the ship made of iron does not. What is the reason? The reason is that the nail is solid and the density of iron is greater than the water. Now student, as I have told you just now, that if you take a tub filled with water and if you drop a nail in this, what will happen? This nail will sink in the water because this iron nail, and this is water, this iron nail is made up of iron and it is very much dense than this water. That is why it will totally sink in water. But whereas when there is a big water body, for example river, ocean, and in this ocean the iron nail, you can see the iron nail floats, the iron ship made up of iron or submarines, they just float in the water, What is the reason? The reason is that the ship splashes the water according to the volume of its lower part. It splashes the water, and then the upward force, that is FB or up thrust, acts on this ship and it helps the ship to move upward, and that is why the ship floats in water, whereas the iron nail sinks in the water. The next is flotation of man. It is easier for a person to swim in sea water than in river water. The reason is that sea water contains salt, so its density is more than the density of river water. The weight of man gets balanced with the less immersed part of his body. Now what happens? Sea water contains salt, whereas river water do not contain salt. That is why it becomes easier for man to swim in sea water, because the weight of man is also much dense, and that is why it balances the Seawater balances the density of man with it, and that is why man is able to float in seawater, and man puts more efforts to float in river water. The reason, because the river water is less dense than the seawater. The next is flotation of iceberg. Again we apply the same method, that is, again we apply the same law, that is law of flotation. In the similar way, we have the example of submarine, iceberg, and whales and balloons. Now student, you have to go through these example by your own. Next time, in the next part, we will just do our question answers, and we will also try to understand the numerical parts. Thank you.